every character in this word, we're doubling it, um, and adding it into this string, this empty string. So if we return this empty string, it should work. Um, Move on to the next problem. Um, it says return the number of times that the string code appears anywhere in the given string, except we'll accept any letter um, for the D, except any letter for the D. So scope and coup count. So what they're saying is um, they're basically looking for any word that has a CO and then any character here and E, all in 4 characters. This is a very tricky one, but I'll try my best to explain it. So first we will uh, create a variable um called sorry, we'll create a variable called count. Um, and what this does is count. Yeah, so we're trying to count how many times this CO any character E comes out. So this is basically our answer, and this is where we'll store our answer. And then now we'll the idea here um is we're gonna try to make like a tiny window of like 4 characters that'll check through um 4 characters at a time. So it would check like this and then like this and then like this um through the string. So you could kind of see this highlight as like a window. Um and then the program will basically check if um this code or cope or coup appears in this window. And as you can see, code appears here, so that's why there's one. Then code, and that's why there's two. So that's basically what we're gonna do. What we're gonna do. So now we'll create a for loop um in all right. So in this example, we'll be instead of looping through this string, we'll actually um loop it through the length of this string. So so yeah, string. So the reason why I added this range here was because if we just do the do length, um it actually what we're aiming to get is the uh here um basically just the length function um will show you the wrong length, the wrong number of sorry, what we're trying to get in the for loop is the index of each character and not the length. So that's why the range function is important, so that it shows as 0 through, let's say in this example there's 9 characters, sorry, there's 10 characters, so it would show through 0 through 9 instead of just uh, 10, because there's 10 characters and that's what length function will show. And also 10 is not iterable, so it would just give you an error. Let's keep that in mind because that will come up in a couple other examples. Um, so now we'll create a temporary uh, variable, and as I explained before, this variable called temp will be the small blue window I was talking about. So like it would have four characters, and it will check each time for COE. So what we'll do here is R I plus 4. And the reason why I did I through I plus 4 is because again it starts from it starts from here and plus 4. So plus 4 characters, and it'll end at 4 characters. So that's how we'll make the 4 character window. And and we start with I because we want to keep continuing like this and then like this to check for CO character E. And so yeah, that's like the window. And now we'll check through an if statement, um if the um the thing that we're uh now through an if statement we'll see if um we'll have this code in our string. So basically what we'll do is 0 2 equals C. So we got the first part here. Um, it says temp 0 0:2 equals CO. So what this is checking right now is, let's say for in this example it shows 4 characters, and like this window it is showing ZEXX, and it's checking if the it's it's checking if the first 2 characters of of ZEXX equals CO, because in here it says that we need CO and an E, right? So in this case it wouldn't work, but uh, we'll go on. And the other thing that this problem requires us to do is have an E at the end, right? So then we'll add an and check if the last letter has an E. So basically, yeah, we're using negative indexing here to find the last uh, last character of the string, and and we could check. So if these requirements um are met, that means we found one that says code or codes or whatever it's COE. Um and so yeah, that's basically how kind of the uh, kind of the how the window kind of slides through. So basically, I'll just recap. We're making in this code we're making kind of a sort of a window that checks through um, like this to check if the window sees COE, and um, it will go like this all the way until here. But we're missing an important thing, and it goes all the way back to um, right here. And we can see that although um, it says this seems correct, It's actually not, because since the four character window, the window that's supposed to show four characters, if it reaches all the way here, and then it tries to start at let's say B here, there's nowhere to go, and it would just create extra things, and it just won't work properly. So that's why it's important to for us, right, to add sorry to subtract 3. Why? Because if because we don't want the window here that reached that starts from here, we don't want the window sliding to here because there's nothing at the end. So we want the window to stop here, but then read all the way through the end. And so if this works, which it should, um, yeah, we just return count, and yeah, it should all work. So if you don't understand this, it's very tricky, and I had a little, I needed a little time understanding this one too. So um, yeah, all right, but the next one should be a bit easier, uh, which is count high. All right, the problem's pretty short here. It says return the number of times that the string high appears anywhere in the given string. All right, so it gives us 3 examples right here. We could see that for this one, there's one high right here. There's 2 highs right here, which gives us 2, and 2 highs right here, it also gives us 2. So yeah, basically, we're trying to find how many highs there are in a string. First, I want to um oh, actually, this one's actually very um actually, I want to actually ask anyone um that knows the answer to this problem, because we could actually answer this problem with one function. If anyone knows, you could type it in Q&A. Um, there's one function in Python that can count how many um number of um strings there are for in a certain string. All right. Nobody knows. That's actually, we got someone. Yes, that is correct. It's very smart. All right. It is the count function that count, and then we could just put high because that's what we're trying to count. So what this is doing is counting how many times high is in, and this basically this function will just do the work for us. And yeah, we have all incorrect. All right. Next question says end other. Now this one, as we can see, we have 2 strings right here. It says given 2 strings, return true or false. Return true if either of the strings appear at the very end of the other string, ignoring upper and lower case differences. In other words, the computation should not be case sensitive. Note: s dot lower returns the lowercase version of a string. So they're kind of giving us a hint right here. Um, so they want us to find anything that's anything that's similar. So Um, and they want us first to know that um, they don't want us seeing any um, uppercase or lowercase. So um, um, if okay, so for example, if there's ABC right here and ABC right here, um, it should equal true because they have uh, they have ABCs in both strings. But for this example, there's capital A, B, and capital C. But in this example, there's lowercase a, capital B, and a lowercase c. That's different, but they both have the same um, characters basically in the English language, so it would return true. And to fix this problem, they first kind of gave us a hint right here. It says s dot lower returns the lowercase version of a string. So using that function, um, we can we can create we can uh, make both of these strings lower so that there's no difference in case, meaning that there wouldn't be anything that would be case sensitive. So what we want to do first is declare um, a variable. Um, First, we'll declare for a, so a dot lower to make this whole string lowercase, and do the same thing with b, which is a b dot lower, and actually, yeah, and then so what we did just now is declare variables that will uh, um that will be set to these uh these strings, but they're lowered. So for this first example, what a would look like is ABC, and what b would look like is HIABC. B would look like this, and a would look like this. No uppercase because of the lower function. And then we will um return um okay if a. So now I'm gonna be using this weird function that I barely use. Um, yeah. Well, I haven't really had much experience with this function, but it's pretty convenient. So it's called ends with, and um, what this is doing is it's gonna send us true or false if if a this a so if ABC ends with HIABC, and we could see that it does. Um, it has ABC, and um, the ending characters also have the same characters. So this would come out true, but we also just want to write it the other way. So it would be B dot ends with A. The reason why is because in another case, these characters might be switched. So A would be HIABC, and B would be ABC, just ABC, and we want to just check if either of these end with um, ABC or whatever, or end with each other. And this should be it. Uh, it's a very convenient function that's just there in Python, and should be all correct. All right, we'll move on to the next problem. Um, end. Oh, sorry, I just did that one. Cat dog. This one is pretty pretty easy. It's just I think it just gives us one line, but here it says return true if cat and dog appear the same number of times given in the string. So we can see right here cat, dog. There's one cat, there's one dog, so it would uh, give us true. There's two cats but zero dogs, so this function will give us false. There's one cat, and there's a cat and a dog, which would show that there's one dog and one cat, and it would give us true. And this is actually very simple and very similar to the other one, but um, here if we this can be solved with one line where if string dot count cat equals, so remember this is if it equals, not just equals, but if equals uh, s- um, string dot count equals dot. So this is actually very simple. So the count is counting how many cats there are, and the and yeah, for this one it counts how many dogs there are. So and what this is doing is comparing, this equal sign is comparing if this number is the same as this number, and if it isn't, it gives us false, and if they're both the same, then they'll give us true. So yeah, it should be correct. We'll move on. um Last one for string 2. We'll move on to list 2. All right, so this one says return true if the given string contains an appearance of XYZ, where the XYZ is not directly preceded by a period. So XXYZ counts, but X dot XYZ does not count. So yeah, basically what preceded means is if there's no dot before before XYZ. In this case, it would be true because um, there's XYZ. But in the next case, it would be false because there's a dot XYZ. And uh, for this one, it would be true because there's no a period or yeah, a dot um, before the XYZ, but actually after, so it would still count. So how do we do this? It seems kind of complicated, or maybe not, but this one can also be answered in one line. And um, basically, what we're just gonna do is um, count how many times X, Y, Z comes out, and count how many times um, dot X, Y, Z comes out. And we have to put an operator here. So we want to put if we want to see if uh, XYZ comes out. So and if it does come out, it want to be true. So what we actually need to do is put a greater sign right here, so that if the amount of XYZ is greater than dot XYZ, um, then it's true. But if this is greater than XYZ, then it shows false. And this should work because there should be only one. So there should be only a case of either um, um, one one of this and zero, or um, one of this, or actually one or more. So yeah, there's either one, and so basically, yeah, this is just very simple way of approaching this problem, and yeah, it should work. Alrighty, we are now going to move on to list two. Sorry, I'm gonna stop sharing and then share back. Can everyone see this? I hope so. So first problem we'll be approaching is not evens. So um, um, this problem states return the number of even ints in the given array or the given list. Note the percent mod operator computes the remainder computes the remainder. So first, what we'll do is oh, so basically we'll just sorry, my mind just went blank. So what we're doing is finding how many ints there are um um in a function. So and in this example, it would show that there's three even numbers or even integers because there's two, two, and four, and that would be three integers. For here, it would show three because zero is also an integer in Python, and in uh, in this one there's no integers, so it will show as zero. So we can easily tackle this problem. First we will make a variable to count how many evens there are. So we'll first set it to zero, and then now we'll loop through the list of nums. So for I num nums, um, and then for each I or for each number, we'll check if the number is an even number, and so if it is, if I 2 equals 0.
자,
So what this
우리
mod does is give us um um a um a remainder, a remainder basically. So let's say for example I was 4. So then uh if I was 4, then 4 divided by 2 equals 0, right? But if I was 3, then I divided by 2 would be a fraction, right? And that means which means that it's not an even number. And the mod will actually give you if um if I equals 3, then this mod would actually give you 1 because the remainder is 1, because um, two uh, two can only get two can go into three uh once, and the remaining the um remainder is one. So yeah, so this is basically just checking if I is even, and if it is, then um, we add one to count, and we are done. We just return count. That is correct. All right. This question states, return the number of numbers in the array, returning 0 for an empty array, except number 13. Except the number 13 is very unlucky, so it does not count, and the numbers that come immediately after 13, 13 also does not count. So, for in the first example they give us, in the first example they give us, there is no 13, so it would just add up all of these integers and give us 6. And same for here. But in this example, it gives us a 13, but right at the end. Um, so then there would be nothing because it says that except number 13 and the number immediately after 13. So 13 and the number after 13 will be skipped. So then but then that rule would only apply to 13 because there's no number beyond 13. So it would just be 6. In an example where if this was 13 and this was 1, um then the answer will be 5 because there will be 13 here, and the number immediately after 13 is also skipped, so this whole thing would be skipped, and the answer would give us 5. So the first thing to do in this problem is um, create we are going to create a for loop. Sorry, for I in, and then as I explained before, we are going to create range of where we are going to get length the range of the length of nums. So in this for loop, the reason why we use this for loop is to make use of indexes, and you will see why later. But yeah, that's um one of the main reasons why we're using range length nums instead of looping through the list. All right. Now we'll check if the um, if nums of I equal to 13. So we're just going to loop through the and check if the list here is sorry, the number that we're looking on um, each list, sorry, on each index on the list is 13. And let's say it is, then um, uh, nums I equals 0. So basically, we just don't want anything to do with um, that number. So we're just going to um um edit this list. Okay, I'll be using this list as an example. But we'll be editing this list so that that number, so this number right here would equal 0. And basically what we're going to do is return and use the sum of nums. And this is important right here so that we can get the sum of this um, whole list um, without without adding the 13. Now, in the if statement, we want to create another if statement, checking if sorry, checking if um checking the length nums. So basically, what this is doing is uh it's checking if the the number in the range. So in this example, the number the range is 5, so it would be um, 0, 1, 2, 3, 4. That would be the range. Um, if the rate this if a number if I is less than the length of nums, which would be this nums minus 1. So yeah, the reason why we do minus 1 is um because length gives us instead of 4, because we're using index, it would give us 5, and it would give us the actual length of the list. So that's why we are minus 1, so that we could keep using the index. So yeah, and if it does, so basically um if I is less than the maximum, basically, um then um let make nums plus 1 also equal to 0. So what this is doing is doing the same doing um this doing this what this line of code is doing, but it's making 0 for the um, number right next to it. So remember, in this problem it says no, the number 13 and the number that it comes immediately after 13, so does not count. So basically what this if statement is checking is if the number um, is not the last number, like in this example, it shows that 13 is the uh, last number. But if it is not the last number, then we would make the next number um, 0, 2, because of this condition right here. And so yeah, and basically that's basic that's mostly it. And yeah, so if we run this code, we should get the sum of 13 of everything except 13 and the number after it. and it worked. Yep. All right, we'll move on. All right, that one was kind of hard, so I believe this one should be very. This one would be a bit easier, a little bit of a breather. It says, it states, given an array or a list, length one or more of ints, return the difference between the largest and the smallest value in the array. Note, the built-in min and max functions return the smaller or larger of the two values. So, uh, what this, sorry, whoa, um, what this problem is asking is give us the greatest number in a list and the smallest number in the list and subtract them. And this is actually very simple. Um, they gave us a hint called the min and max function. Does anyone can anyone take a guess on what the answer is? Because it's just one line. You just return, and it's very simple. I want to see if anyone can answer it in the Q&A. If anyone can answer this question, it's just one line using the min and max function. All right, we have one person typing. You don't have to like write the whole thing. It's you just write just the line. Okay, I mean it's fine if nobody knows. But, or actually, never mind. It's typing. Or okay, um, I'll just um move on. Um, it's actually very simple and just uses one line. We get the maximum um of nums. Yes, yes. See, I just saw that um, in the Q&A chat. It's just maximum of nums subtracted by minimum of nums. So what max gives us is the greatest number and min's the smallest number. And we're just subtracting. And we're putting max first because, in math, we don't want uh, it, we don't want the answer to be negative. So we're always gonna put the max first, the greatest number first. So everything should be correct. Let's move on to next example. Next one. All right. So this one's kind of simple, but it's also kind of hard. Um, it says return the sum of numbers in an array, except ignore sections of the numbers starting with a six and extending to to the next six. Every six will be followed by at least one seven. Return zero for no numbers. All right. So what this is basically telling us is that if you find a six, ignore everything above six until you see a seven. For example, um, in this in this uh, in this example, it shows one, two, two, and then a six, right? So we're gonna ignore 6 and beyond until we find a 7. So we see 6 and then a 99, 99, and then a 7. That means everything here we're going to ignore. So the answer would be 2 plus 2 plus 1, which is 5. If and in this example, it shows that it shows 1 1, 6, and 7. So we're going to ignore everything here and keep moving along, which which is right here. And then that means we'll do 1 plus 1, which is 2, plus 2, which is 4. Now, how do we do this problem? First, we'll declare a boolean. We'll just name it like found 6. Now, this this boolean will check if um sorry, this boolean will check if we found 6 or not in the um in the if statements in the for loop, and I'll explain later as we continue this problem. And then next we'll declare uh, a variable called sum, um, and we'll set it to 0. This is basically just um, our our answer. So yeah, now we'll loop through nums. So we'll loop through the array, and um, and then we'll do if statements to check if these if these conditions are matching or not. So first we'll we'll see if we found 6, and to do that we'll do if I if a number is equal to 6. If it is, then found 6 is true, because yeah, and uh, this is where we get to use the um found 6 boolean. So we'll check if we found 6 and n equals 7, meaning that if we found a 7 and and we already found 6, um that means to for us to make found 6 false. False. The reason why we're making it like this is because, okay, so what this first line does, first um, condition does is if found 6, and if we just leave it as if found 6 and not if found 6 equals true, um, Python will assume that you're just saying if found 6 equals true, and then it says n equals 7. So if we found 6 and there's a 7, that means uh, found 6 equals false, and we will stop skipping basically. So instead of finding a 7, a random 7, and no 6 before. Okay, actually, let me explain like this. If this 2 was here, if this 2 here was a 7, that and we created this if statement, so it's like this, it wouldn't work, because then it would skip everything. um the code wouldn't work, because that's not how the conditions are meant to be. So that's why we use the found 6 boolean. And then lastly, we'll just create this last if statement. Found 6 is false, and this is checking if found 6 equals false, meaning that if we've if we are after 7 or before 6, add to sum plus equals 1, and then we return sum. Yeah, basically we're just adding one all of these before we meet 6, and yeah, that should work. Mm, and it's not defined. Oh, I'm sorry. Not n. Right. Oh, wrong. I meant I, not 1. Mm. Oh, the reason why. Oh, this the okay. So the reason why this is wrong is because we forgot. I forgot this one bit. It's called continue. This block, this code basically tells the program to now uh skip. So because in this statement we've said that when we found 7, we want to uh we don't want to count 7 in. That's why we skip 7 and go to the next number. So basically, yeah. And yeah, that should be correct. Sorry, that was my mistake. Next question. Centered average. um okay, this problem says return the centered average of any array of ints, which we'll say is the mean average of the values, except ignoring the largest and smallest values in the array. If there are multiple copies of the smallest value, ignore just one copy, and likewise for the largest value. Use int division to produce the final average. You may assume that the array is length 3 or more. So this is asking us to um, for us to find the largest and smallest value, and just uh, I think just take them away, and find the average. So in this example they showed 1, 2, 3, 400. The smallest value would be 1, so we would take this away, and the greatest value would be 100. Now we're left with 2, 3, 4, and um, the the average, or the average of 2, 3, 4 should be 3, and it gives us 3. Um, in this one, it shows that it shows 1, 1, 5, 5, 10, 8, 7. The greatest uh, value is 1, and the smallest value is 1, and the greatest value is 10. If we take those out and then do them kind of do the math basically, uh we should get through 3. So yeah, to solve this problem we will first get um, we will first declare three variables: sum one, min one, and max one. One mistake that I made is that, oh yeah, actually, never mind. We were declaring the sum, the minimum, or the least or the smallest value of the of the list and the greatest value of the list. So for this one, we will simply use the sum function, so sum of nums, and for this one we'll use the min function, min of nums, and this one the max function, so max. And now all we simply have to do is find, just return average. Um, Now, to find the average, for let's say a regular, just find let's say this problem did not exist. To find an average of this array, we would have to just add all of these together and divide them by how many um, numbers there are in this list. So, for example, we'll just add um, all of this and divide it by 1, 2, 3, 4, 5. And but in this situation, we are trying to get rid of the get rid of um, the minimum and maximum of the list. So we would get the sum of the nums, but um, we would get rid of it by doing min min one and then minus max. We are getting rid of this. We are getting rid of this by subtracting it um, by the sum, and then we will divide. We are floor. We're using a floor um, to round. I believe so. Yeah, we are using the floor function to round down. Using the double forward slash, and then we will do length of nums minus 2. So basically, we did nums minus 2 to find the average, but since we got rid of the minimum and maximum, we are subtracting the number of how many we took out of. So yeah, it should be correct. I'll explain it like this. We're subtracting from 2 because we're taking out 1 and 100, and now the length should be 3 because we only have 2, 3, and 4. Because of this subtraction, which we did here, and that's why it's correct. Oh, that was very long, but we'll get through the last one. Last one is very simple. So, um, given the array of its, return true if the array contains a 2 next to a 2 somewhere. So, yeah. So it's if there's a 2 and a 2 next to each other, it gives us true. This one gives us false because there's a 1 in the middle of these two, and false here too. So how do we solve this? Uh, we would have to first use. We're gonna for this problem we'll use indexing. We'll use indexing and with a for loop. So for I in again range of length of nums. We're doing this to get the index of 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 the nums, and we'll say if um if nums of I, so if that particular number is equal to 2 and nums of I plus 1 equals to 2, turn true. And so what this line of statement is saying um is that if the number you're looking at is 2, and since it's I plus 1, we're looking at the index 1 ahead. And if that's true, if that's 2, that means we'll just return true, because it says if any 2 has a 2 next to it. So we'll return true, and when we return true, this um, this whole function right here will exit out and just give the program true. But and so to make this very simple, we'll put a return false instead of adding an else, because if we loop through all of this and find out that there we couldn't satisfy this if statement and exit exit the function like this, then the Python code will continue and exit out of the for loop and return false, because there was nothing that came out true. So yeah, index out of range. Let's see. Oh, -1. And so yeah, that's basically it. Sorry, the reason why it was -1 is because if there's we're just checking until right here. We're checking until the second last, because we want to check like this. But if we check here, there's no number to go one ahead, which would give us an error. And that's why we have to uh, -1, so that we can restrict the computer from checking like this, which will give us an error. And yeah, that is correct. All right, that was long, but thank you. It was a pleasure to teach you. Thank you.
I'll be taking over the class. I think I'm the next teacher that's up. So I'm going to be going over Python 1 document. It was sent to you guys as homework. I'm also not sure how many of you actually finished the homework, so we'll go through it together. I'll show you guys the question, and then you guys can answer in the Q&A chat. Here we go. All right. This is the, yes, correct document. All right, so this is our first question. Consider the following expression: result 8 floor division 6 mod 5 plus 2 power to the power of 3 minus 2. So it is this equation here. What is result? What is result? You guys can answer in the Q&A chat if it's hard to see. Here is the question again. The answer choices you guys have are 6, 9, 8, and 7. All right, we got 2 sevens. I think that's all we're gonna get. 7 is the correct answer. So yeah. So Python calculation is just like how we do real life calculations. The order of operation is exactly the same. So we start from everything inside of parentheses goes very first. Then we do powers. Then we follow the then we do exponents, powers, exponents, same thing. So we follow the ways of PEMDAS. I don't know if you guys learned it this way. So it's parentheses, exponents, then multiplication and division. They come together. So uh, whatever comes first in the order whatever comes first in the equation order, you use it. Same with mod here and floor division. So both floor division and modulus are on the same, I guess, level of operation as multiplication and division. So keep that in mind. And then finally, you do subtraction and addition, such as plus and minuses. So the correct answer is 7. Next, consider the following list. So we have a list here. N1 is 10 to 50. N2 is also 10 to 50. What is the output? One is compared by N1 is N2. The other is compared by N1 equals N2. You got false true, false true. All right. 3, which is also false true. Yep. So you guys are all correct. So anyone have any ideas why this might be like this? Why the is command does not work? Because is still asking if it's the same thing. Like, why wouldn't that one work? So this goes into a bit deeper into how Python works and how these coding languages work in general. So equals signs are used for the values. So if we think so, the n1 and n2 has the exact same values inside them. However, when is used is when n1 and n2 are the same thing. How is it different? In order for the first print statement, so in order for this question to become true, instead of setting n1 and n2 separately, you would have to set n1, and then you would have to do n2 equals n1 when making n2. This is a complex concept called a reference. So where Python thinks that variable is located at, that's when is used. So for now, just know that equals is comparing the actual values, and then equals comparing the actual values, and then n1 to n2, and then is comparing if those two are actually equal, as in they were set together or set one equal to the other. Next, question 3. We have 5 choices here. Yep. Consider the code A, B, space, C, D. There's a list that takes in list S, so that's a list function. List dot append EF and print list. What is the list being printed as? You guys have 5 choices here. Remember, list function turns things into a list. In this case, it's turning a string into a list. How would it do that? And if so, what is the result? Right, we got someone typing here. Oh, okay. Any guesses? Random guesses are fine. No one's here to judge. So yeah, our teacher actually already gave you guys a great hint. Tuple is parentheses, list is big brackets, and curly brackets is set or dictionary. That already narrows it down to 3 out of the 5. Which one would it be? Oh, there's a network problem. Uh, is it impacting the class? Oh, that's problematic. Yeah, thank you, Ian. That is the current question that we're. If you guys can hear us, uh, that's I think more than good enough. So that is the question we're trying to solve right now. If you if the it's in the playground chat right now. If you guys can load that one up, that would also work. So which one would the answer be? Actually, a good question. Can you guys hear me speaking? Okay. Slightly. mm, All right, we got our first. We, so you guys, can you guys still not hear me? One. All right. Uh, if you guys can hear me, we'll hold on to the class until the current problem is at least somewhat resolved. Oh, okay. All right. Thanks, God. Excellent. All right, we'll continue on the class. So we got our answer of A, big brackets A, B, C, D, E, F, and then which was number 4. Yes. So the correct answer is number 4. The reasoning behind this is if you turn a string into a list, every single character is turned into an element of a list. So we can first where's the annotate? I can first cross out these two because they're not even using big brackets, which we must. And then this one, it did not include the space that's in between these two, which was okay. Is the audio problem back? Or the screen share, I guess. All right. Uh continuing back with the class. So every character it has to be part of it. And because all right, yep, here we go. So these two are using the wrong brackets, so they shouldn't even be a consideration in the first place. And then when the second line is ran, it becomes AB. This is way too thick. It becomes A B space C and D. All 5 of those are separate elements because individually one of them is defined as a separate character. And then when we actually append EF, those are appended together and not turned into a list. So they're appended together as a string of EF, which makes number 4 the correct answer. That does that. All right. Next one, question 4. Following some anomalies. Consider the following expression. This is the number of operations again, same as question 1. Don't use a calculator. Let's see what you guys can do. Order of operation. Remember, double stars are exponents. And other than that, fire away. Got our first answers coming up. Maybe. We got 17. 17. The correct answer is, in fact, 17. If you follow the order of operations, it becomes 7 to the power of 2, which is 49, and then becomes 98. 98 minus 98 minus this part becomes 81 eventually. So 98 minus 81 is 17. You guys are correct. Good job. All right, question 5, bit of a long one. So we have 3 code segments up here. And after executing code segment 1, 2, and 3, the result type of 1, 2, and 3. What type is it? Segment is up here. This is probably in your homework doc somewhere. If you guys want a better look as well. Yep, it's the most recent one actually. The Python underscore one.pdf. That is what we're solving. Any guesses? Or I guess types. What is the type of C1? What is the type of C2? And what is the type of C3? So we got 2 here. Oh, here's the multiple choice if you guys want to see it. We got string int float, which is number 2. String float float. Interesting. And then string float float. So that would be number 1, right? Yeah. And I see a couple of changed answer to number 1s. All right, so the correct answer is number 1. So first one, because there's already you already set a 10 as a string. If you multiply by an integer, it becomes 101010. Just that string written 3 times in a row with nothing in between. So that's why C1 is a string. As for the code segment 2, both start out with integers, but because this is not a floor division and just normal division, if you divide anything in Python, if you do division, the return is always a float unless you cast it into an integer. So it was float here. Same here. The start can be one float, one integer, or it can be both integer or both floats. Does not matter. If you divide something in Python, unless you cast it separately, it is always going to be a float. Good job. It is number 1. We have an even smaller piece of code here. So in order to make the value of a into 9 at the end of the code, right? So after the code has finished running, what should go in this spot here on line 3? What should be here out of these 4 down here? So we got 3, 2, okay, separate answers. Exciting. Any other guesses? Same as these 2 people or completely different guesses? We got another 2 and another 2. All right, so the correct answer is 2. So if we follow the code here, it first becomes a is 2, and then it's turned into 3 here. So by the time line 2 ends, it's a is 3. So when a is 3, the only way for within this choices to get it to 9 is to power it by 2 or power 2. So it'll be 3 times 3, which is what this one does. Hence, the answer is a to the power of 2. Number 2. All right, next, which variable represents true? We did this yesterday. I taught this yesterday 2 times. What is true? What makes it true? Which values? Remember, the top two are integers and the bottom two are floats. We got B and C. Those are true. Any other guesses? We got a 3. We got another B and C. B and C, which is 3. Yep. All right, the correct answer is B and C. So anything that's not a 0, so this would be false, this would be false. So remember, float 0.0 is still a 0, therefore it is counted as true. If it was like even not 0 by like 0.01 or something, no longer true, it becomes false. And obviously these two, because they have a value set, that's value set that's not 0, they are false. They are true, excuse me. So there's BC. Oh, there was all variables option here, but that's obviously not true. All right. Consider the numbered list. This is where we can explain a bit deeper about what we learned before, but let's go with the guesses first. Order. In order, they're printed. What is the result? What is the result? False, false, true, true, false, true, 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 false, true, false, false, true, false, true. Oops. You guys can answer by just T and Fs if that's easier for you. Which is the correct answer? Any guesses? True and falses. We got 1. All right. Good start. Anyone else? So we got the answer of 1. Oh, we got a different answer. False, true, true, false, which is actually not an option. Oops. And then false, true, false, true. He seems quite confident that would have been number 4. So the correct answer is it's 1. False, false, true, true. So let's break this down one by one. First one, numbers alphabets. Remember, for this to work, they have to be the same, they have to be set as equal to each other. Numbers equals alphabets. That's the only way it will be set. And for the second ones, for the line number 4, for the second line, for the second true and false, this is obviously false as it because, well, these two are just not equal. 10 is not A, 20 is not B, 30 is not C, 40 is nor D, nor is 50 E. So nope, that's false. So we got 2 falses here already. Now we set numbers to alphabets. This is where it gets interesting. So if you look at it here, print number is alphabets. This is where it is true because we set numbers to alphabets. They are located. If you guys learn a bit about computer hardware, there's a thing called RAM or memory, instant memory. Those are located in the same spots under this code. That's what it means. So numbers equals alphabets. You set it to be the same thing. They're now the same variables. They contain the same values, as well as being same enough to be compared to compared with an is comparison. And then obviously because we set them to be the same alphabet, numbers is now A, B, C, D, and E. So numbers in alphabets obviously have the exact same value. So the correct answer is number 1. All right, next. You're developing a Python application for your company. This is a list named employees contain 500 employee names, the last 3 being company management. Which of the following represents only management roles? Careful, or they might come for you and fire you. How do you pick out the last 3 company management? Who's the last 3 on a 500 employee list? You have 4 options here. Any guesses? 1, 2, maybe it's even 3 or 4. Right, we got the first. I'm seeing the first response from chat. We got 2 ones. 1, 1, 1. 1, 1. That is very interesting. So, surprise, surprise. None of you guys got it correct. It is 1, and it is also 4, and it is also 2. Meaning the correct answer is actually number 3. So, if you look at the question here, 500 employees, index of 497. Index 497, 498, 499 is the last index because there's 500 because it starts from 0 instead of 1. So the employee indexes go from 0 to 499. So 497, oh oops, 497, 498 and 499. That is 3. Same with the one right below it. 497 to 500 exclusive, meaning it ends at 499. So it's 497, 498, and then 499 again, 3. If you go to number 4, negative 3. So it goes up till negative 1. So negative 3, negative 2, and negative 1. Huh. All 3 of them are correct. All 3 of them are the last 3 indexes of the list employees. So all 3 of them are correct. The correct answer is number 3. Question 10. You're developing another Python application for a company. You have now an employees list that contains 600 items, 600 names. They grew fast. Last 3 being company management. You need to slice to display all employees excluding company management. This time excluding. How would this one work? You guys are supposed to pick multiple, so there might be multiple correct answers for this question. So tell me all you got. Just give me the 2 things or 3 things or the 4 things or maybe even all 5 things that you think is correct. We got 2 and 5. All right, good start. 2 and 5. Would this be correct? Any other guesses? I see 3 people now, 2 people typing. Any other guesses? 2 and 5 again. 2 and 5. All right, the correct answer is 2 and 5. The reasoning for this is, I think, relatively straightforward. So 0 and negative 3, okay, did not meant to do that. 0 and negative 3 goes from the first one to the, so because negative 3 is exclusive, it actually goes to negative 4. So it would leave negative 3, negative 2, and negative 1 in front of it, not touched. If it's negative 3, because it's again exclusive, not inclusive. So it goes from 0 to the negative fourth index. Remember, 0 is still at the first spot, and negative 4 is way out there. Stops at negative 4, and then negative 3, negative 2, negative 1 is separated and not touched. Same goes for number 5. If you don't remember, if you don't have anything in front or behind for that matter, if you don't have anything in that front, it starts from 0. If you don't have anything behind, it goes all the way till the last possible index. So keep that in mind. So these two mean identical things because this one started at 0 as well. Rest of them do not make sense. This is excluded the first employee for some random reason. This expression as well. Remember, starts from 0, not 1. These two just forgot about one of them. And then this one, it only goes to negative 2 and negative 1 index employees. That's it. Because 0 is at the start. Only the one going from top to bottom starts from negative 1, negative 2. So if there's only 2 people there, it's not going to be right. So the correct answer is 2 and 5. Next question 11. Following Python call code under the math question. Relatively simple. Multiple answers as well. You guys are supposed to pick multiple of them. What is the correct answer? How do you get the how do they become 0 if you solve them? No calculators, please. Should be relatively simple. We got 3, 3, 3. Remember, guys, you guys can choose multiple. This might have multiple results. Whenever this thing's a square, that means there could be a multiple result. Circle, there's only one. Square, there could be more. Can also be one, but they usually don't do that. It's either 2 or more. So we're still holding on with 3. Oh, we got first 3 and 4. 3 and 4 again. 3 and 4. All right, the correct answer is in fact 3 and 4. So if you look at it, 1 to the power of 3 is 1. 1 minus 1 is 0. So this is 0. Remember, mod is in the same realm, same tier level as multiplication and division. So this one goes first. A mod B is 1. Because 1 divided by 3's remainder is 1, because you cannot even divide it in the first place. So 1 minus 1 is 0, so these two are correct. This goes 3 to the power of 2, 3 times 2, which is 6, plus a, which is 1, so it becomes 7. This one becomes, remember, modulus is also on the same level as multiplication and division. Therefore, they go before, so they go first compared to addition and subtraction. So B mod D, B for division D, which is nothing, 0. And A is 1, so 1 minus 0 is still 1. So this is not the answer. Answer is 3 and 4. All right, next. Won't print cat to the console. Pick one. All of these print statements with the variable decided above will give you a cat statement on the module, on the console. You guys can try this one in your own IDE if you guys want to. If it's very close, well, suit yourself. So, which of the following won't print cat to the console? We got our first answer of number 2. Number 3, number 1s. Uh-huh. Is it number 2 or would it be number 1? Get another number 1. Number one. All right, the correct answer is number one. So if you look at it, index of 2 gets out you. Wait, what? Oh, which one won't print cat to the console? Okay, okay, we're good. So 2 is R, 1 is P, Z1 is O. So it would do R, P, O. Not what we're looking for. This one goes from reverse, goes reverse. So -5 is C, 0 is first A, 0 is T, -5 same version, 0 is A, -2 is -1, -2. It's at T. So it's again cat again. And then this one finally x is 1, which is a second index, remember? It would be C, first one A, and then third one also the first index T. So it is in fact number 1, not cat. The following expression, which one is the following is valid? Literally orders of operation, PEMDAS, choose multiple. Remember, this is a square bracket question, so if you guys want to, you guys can choose multiple of them. Any answers? I'll give you guys a hint. There's 2 answers for this question. If you're debating about 2, then you might be right. I got 1, 2, 1, 2, 2, 1, and 2. Okay. The correct answer is 1 and 3. So 1 is obvious. 1 is correct because multiplication goes first anyways. If you put them in the parentheses, it's not going to change anything. They still go first, just as shown in the original one. They still go first because multiplication goes first. And then you guys picked a lot of 2, which is addition, then subtraction. No. It's subtraction, then addition, because, well, that's how it works. Subtraction and addition are on the same level, same tier of playing fields. So whoever is on the front goes first. The correct answer is 1 and 3. The above expression is equivalent to this one because, well, if it was always going to be first anyways, multiplication was always going to be first. It's just now even more firster, if that makes sense to you. Number 14, consider the code. What is the result? Very simple question. Fire away. Thirty one 3.0, 3.013. So someone said 0. So, nice, Martin. Is that 3 or 3.0? Oh, there we go. So all you guys get 3.0. It is correct. If you do division, it outputs a float with the decimals attached. You would have to do floor division to get an int, obviously modulus for remainders. So it is in fact 3.0. You're writing a Python program that evaluates our arithmetic expression. The expression is described as p. I don't know. Which of the following is valid expression for the given requirement? A, eval input, enter number for expression. The expression is described as b is equal So multiplied by -1 it equals a multiplied by -1 raised to the second power after that, and then there you go. So how would you get b? It's a multiplied by -1 and then raised to the second power, where it then becomes b. Which of the following is valid expression for the given requirement? We are 3, 2, 3, 3. The correct answer is 3. So if we put multiplication outside, that means we're doing it last. We're clearly not doing that. Eval. Yeah, I believe it stands for evaluate. I'm not. Uh, Eva. Anyways, the point of the problem is neg- uh it should be inside because it came first. So if you're writing, if you're not sure, always just put parentheses in order because usually words are set in order. But here, -1 multiplied by negative first and then raised to the second power, which we're doing here. You got to keep parentheses. If you don't, it technically it would only raise the number 2, which makes it -4, which we're complete. No, which would make it negative a to the power of 2, which is not what we're going for. You should be getting a to the power of 2. Next, oh yeah, the correct answer therefore was 3. Consider the Python code. Numbers, we have a list. X equals 0. Okay, yeah, eval in the previous one. This one stands for evaluate. So consider the Python code 10, 20, 30, 40. We got numbers list. X is 0. Which are the following cases where 10 will be printed to the console? Remember, numbers includes 10, 20, 30, 10, 20, 30, 40, and then X is set to 0 by default, and you're always printing X. So how does X become 10? Is should be your question. How does X become 10? Any possible answers? Or I in 30, 40, 50. All of those are tuples, by the way. Not that it really matters, but single parentheses means tuples. Fi not in numbers, Fi in numbers, Fi not for if I not in numbers. Any guesses? Any guesses? Also a multiple. Also you guys can also choose multiple for this one. But if you found one, you can say it in chat. I would still love to hear at least one of them. How do you get the last print statement? So print X. How do you make X 10 at the end of the code? Any guesses work? We got 1, 1. Remember, there's 2 answers to these questions, but if you found one at least, you can go ahead. Any other guesses? I'll take 2 more who's typing right now. We got 4. Interesting. And 2. So the correct answer, surprise, surprise, is 2 and 3. So one person got it correct. How do we get there? So for I in 30, 40, 50, I is one of the values 30, 40, 50. Let's look at when it's 30. If I in numbers is I in numbers, is 30 in numbers? Yes, it is. Is 40 in numbers? Yes, it is. So it becomes 20. So it's not true. It is 20, not 10. Second one, 30, 40, 50. Not in numbers. Let's start iterating through it. I is 30. Is 30 in numbers? Yes, it is. Is 40 in numbers? Yes, it is. Is 50 in numbers? No, it isn't. So because this is a not statement, this runs true. Therefore, x is set to 10, and print x is 10. In this case, both 30 and 40 are in numbers. So this code segment runs twice because it runs once when I is 30 and then runs once again when I is 40. So that's how it's done. So it becomes 5 plus 5, which makes x is 10 again. Lastly, is for I in 30, 40, 50, if I not in numbers, this would make so 30 is in numbers, so false, not run. 40 is also not in numbers, so also no. 50 is not in numbers, but however, it's only addition by 5, so the ending result will be x equals 5, not what we're looking for. Mm, all right. We'll wrap up the class now, I believe. We got to question 16. I'll hand this over to who's doing the finish. Aiden Park. Let's let's finish off this class. Thank you guys.
Yeah, I'll be giving the homework for today, and I'll do this really quickly. I don't want to waste your time. So for this project, not project, this for homework, we're going to be doing some more multiple choice problems. It's a pretty long weekend till we meet again. So if you haven't finished the multiple choice 1 and 2, please do that before our next class. And on top of that, we're also going to give you 3 and 4, to my knowledge. So you're gonna have to do 4 multiple choice sets. I think each of them are about 40. Or maybe it's just 3. I'm not entirely sure. 3 or 4 multiple choice sets, and on top of that, you're going to want to do um, a simple project. Actually, I think it's a few simple projects, but um, yeah, you're gonna want to do that as well. I think I can probably put that in the homework channel. So yeah, you're going to have to do the multiple choice problems and the simple projects in that I just sent. And yeah, if no one has any other questions, I think we'll be done for the day. Enjoy your weekend and your holidays. Bye.